Water treatment plants provide a vital resource to our communities: drinkable water. The systems that control these plants could be targeted by unauthorized cyber access to damage pumps, open or close valves, cause overflows, inject excess disinfectants, release contaminated water, and disable critical alarms. The Department of Homeland Security's Cybersecurity and Infrastructure Security Agency developed CELR to support its mission in leading the national effort to understand, manage, and reduce risk to our cyber and physical infrastructure. CELR stands for Control Environment Laboratory Resource and is comprised of multiple critical infrastructure platforms, such as a water treatment platform. They enable government, academia, and industry partners to experience the possible adverse effects of cyber-physical attacks. CELR allows users to perform security research on platforms that resemble industrial control systems. The CELR water treatment platform is a scaled-down model of a real water treatment plant. Drinking water plants generally draw influent from groundwater or surface waters. The water goes through a series of primary treatments, a secondary disinfection process, and finally, the clean water is sent to storage, ready to flow through the pipes to your home. The water treatment platform uses a large tank reservoir to represent a water source like a river or aquifer. Ultraviolet treatment degrades harmful chlorination byproducts, such as chloramines, and treatment and disinfection of influent water are often achieved by ozonation. The water treatment platform uses 3 columns to house the UV and ozonation disinfection unit operations. Potable water demand fluctuates in a 24-hour cycle. For example, there is a spike in usage when people return from work at the end of the day. To meet this demand with constant treatment processes, storage tanks and towers are employed. The water treatment platform stores disinfected water in a large tower. The platform simulates fluctuations in demand using an out-of-band controller. All of the described model processes and components are incorporated into 2 mobile units. One cart includes all the digital controllers and computers, and the other includes the physical process equipment. The water treatment platform is controlled by SCADA software, the systems that are employed in large-scale water treatment for process visualization and automation. On the water treatment platform, the SCADA software allows a user to control various set points, such as levels and flow rates. The SCADA server communicates with 3 in-band controllers, one for each unit operation represented on the platform. The water treatment platform also includes a local HMI that displays the ground truth of the system, as it is only connected to the out-of-band controller. The water treatment platform is designed to display upset conditions caused by cyber interactions in a visual manner. These conditions include things such as variance in the UV and ozonation process, as well as overflow conditions. Finally, the CELR water treatment platform is also equipped with Red Team, Blue Team tools. The Department of Energy's Pacific Northwest National Laboratory is supporting the construction and operations of CELR platforms. Our mission is to arm our nation's critical infrastructure with the tools necessary to protect and provide the utilities that drive our everyday lives.
Connect with us to learn how you could use the CELR platforms.